Hello, my name is Naveen, and I'll be presenting on the topic of blockchain. What is blockchain? Blockchain is essentially a shared public ledger of transactions that anyone inside the network can view and inspect, and there is no single authority or an entity that controls it. So let's break it down into four distinct properties of a blockchain. So, number one, distributed. Number two is immutable. Number three is consensus. And number four, it's sort of add-on feature, but it's called smart information. We'll come to that later on. So number one, distributed. This means that every single node or a participant or a peer inside the network has the same data and the complete data available, and there is no single central authority to store or manage the data and the transactions. So number two, immutable. Wikipedia defines immutability as an object whose state cannot be modified after it is created. This means that with blockchain, whenever a block is created and is added to the chain, it means that no single person inside the chain can go back and modify the contents of this block. This gives very high tolerance to change inside the chain. Number three is consensus. Consensus rules are the specific set of rules that all full nodes inside the chain must follow and must enforce when considering the validity of the block and its transactions. So whenever a block is being prepared or is being built, it needs to follow the set of rules. And every block is built by doing some work using some sort of a proof of work algorithm. For example, in Bitcoin, the proof of work algorithm is called hashcash. What essentially is proof of work is it's just an algorithm that makes sure that a block is created only after performing some work, and it's not created out of thin air. Number four is smart information. Because everything inside a blockchain can be coded, a transaction can be this, it can have a set of rules that executes when certain conditions are met. There can be small programs that govern when and how the money is delivered. This gives scope to a whole lot of other fields other than financial transactions, such as smart contracts, business process execution, notary, all other stuff. Let's get into the details of a block. A block has a block number or an index, a timestamp, nonce or proof of work, data or transaction, previous block's hash, and the current block's hash. Let's now skip to the demo. So yeah, coming back to this, a blockchain can be described as a chain of blocks. The link between each block is the hash of the previous block and this block. So block number two clearly shows that one of the key components of this block is the previous block's hash. This is how they are linked together or chained together. The beauty of blockchain is that you cannot modify it once it's done. So let's say I want to add some new information. So every single block after this is invalidated. Let's say I come to here and I just add this. So every single block after the block 3 is red, showing that it's invalid. But everything before that is valid. How does this help us? This helps us when there are multiple peers in the blockchain, right, in the network. So if I have one copy of data, it it is proven to be false by the rest of the peers. There's a process called mining. Mining is the process wherein you find this data. It's called nonce. Nonce is the proof that says that you have done some work to find the block or create this block. So, for example, uh, let's say I say this is a present. So this block is invalid until and unless it's mined. So what happens right now during mining is that this value of nonce, it keeps on increasing until a particular hash is found. This hash needs to follow a set of rules or regulations. For example, it can be in a way that the first four digits are zeros, or the last four digits are zeros, or maybe it's divisible by 9 or something like that. So there is some sort of work that happens by your node to create this block. Let's click mine and wait for the result. Now, if you can see, the nonce has changed to 78,962. Now this block is valid. So if we go back to the chain, I can absolutely mine this block, and then this becomes valid. I can mine the rest of the blocks that come after that. It will take a little bit of time. So now the entire chain that resides in my local data is all valid. But the problem here is that I have data that is different from the rest of the chain. Block number 3 has a hash of 00002729, but in here it says B901, and so does peer C. In peer C, it also says B901, which means that all the other nodes in the network say that whatever information I have is false and that I have to correct myself. That's number 1. Number 2 is, since the number of nodes or number of peers or number of blocks at this point in time is high, it's impossible for me to make a change at block number 3 and then mine, let's say, 100,000 blocks, because it would involve a whole lot of computational effort that would make it completely infeasible for me to gain any returns that would come out of mining such huge quantity of data. Let's have a look at how financial transactions would happen using a blockchain. So, one of the key things that we have to remember is the first block of a blockchain is called the Genesis block. It is usually represented using a series of zeros, or it can be, as with Bitcoin, it was signed with Satoshi Nakamoto's key. So let's have a look at the coin-based transactions. All the transactions are recorded as shown here, and then the hash is calculated. What does this mean? Any change in the data will invalidate all the nodes in the block. This is one of the best features of blockchain. Let's have a look at what is implemented. There are 3 files: miner.py, config.py, and wallet.py. In miner.py, this is a program that defines what a block is with the following features: index, timestamp, data, previous hash, and the current hash. It creates a Genesis block, which is the first ever block in the blockchain. It has a proof of work algorithm implementation. In here, we use a simple proof of work algorithm where we check if the month or the number is divisible by 9 and then the previous proof. If so, that is the nonce, or else it keeps on checking. We have the mining implementation where the program keeps on mining for new currency, as well as it finds if there are new transactions or new blocks being added to this blockchain. There is a small consensus algorithm where we check if the block makes this chain the longest or not. If so, that is the block to be added. If not, we find for the longest chain. This route /blocks would give us a list of all the transactions, all the blocks in the blockchain. Transaction is what gives us individual transactions, or is used to create new and individual transactions. Let's have a look at wallet.py. In wallet.py, it is a simple program wherein there are three options. Number one is to create a wallet or a public and a private key pair. Number two is to send money from your wallet to someone else's wallet. For this option, you will need access to your own wallet key and the receiver's wallet key, as well as the money to send. In the third one, you just check for the transaction. In the check transaction function, it asks a request in the /blocks route in mine file, which can be found right here. This is what is presented as the output for the result, option 3. This is part 3 of the implementation. As we can remember, miner.py is used to mine and validate transactions. Config.py has our configuration information such as the wallet key and the node URL. Wallet.py is used to create or check the transactions. Let's have a look at how miner.py works. So as you can see here, this program continuously starts mining for new currency or new blocks. So from this network, and it's mining to this key. This is my own personal key that I generated as of yesterday. This is the key that is being, so this address is being added with 1 till now. So I have a total of 9 because of 9 blocks. Let's have a look at how the transactions happen. As I said before, we have 3 options. One is to generate a new wallet, second one is to send coins to another wallet, and the third one is to check for transactions. Since I already have a wallet address, let me generate another wallet address so that I can transact between these two. Name of yours, this is the file name. So if you can come here, the second key.txt has a new public wallet address and a private key. Now, to do the transaction, you can just select the option number 2. I have to introduce my wallet address, which is the public key, which is in here, which is this one. Now I have to introduce my private key so that the message can be signed. Now I have to send it to a person, right? His or her public key is to be entered as it's this one. Now I can say, let's say I want to send 5. Now it's just a confirmation. It's asking from this private key, this public key to this person. Amount 5 is being transacted. Yes. Transaction submission successful. Press any key to exit. At this point, if we go here, you can see that there's a new transaction happening. While it is being mined, there's a parallel process that checks for new transactions, puts those transactions inside a block, and creates a block. The next block that will appear right now would have 2 things. One is the new currency that was mined, and the second one is a new transaction that just happened. This transaction and new mined currency would be present in the next block. Let's wait and see if it happens or not. It will take a little bit of time because it has to find the correct nonce to verify this transaction, and as we know, it is always mining. So there are two things that are happening. So this is what essentially blockchain is, right? We need to do a lot of work in order to get the result. So we have it right here. This block, the block number 13, has two things. One is the mined currency, and the other one is the transaction. There we have it. This is a simple implementation of a blockchain. Thank you very much.